Moving on to the next question of this exercise, question number 17. What does the question say? If A, B, C, D are in GP, prove that A power n plus B power n, comma, B power n plus C power n, comma, C power n plus D power n are in GP. If you are supposed to prove this, how will we go about proving this? Let's take a look at this question. So if A, B, C, D are in GP, you can clearly say that let B is equal to AR, C is equal to AR square, D is equal to A R power 3. Is that okay? Yes. A, B, C, D are in GP. First term is A. Assume the common ratios are, and we can write B, C and D in this manner. Is that okay? Yes. What else? A power n plus B power n. Let's take a look at this. A power n plus B power n will be equal to what? A power n is okay. This is A power n R power n. Is it not? Yes. This is simply A power n can be taken out common, 1 plus R power n. Yes. Yes. What about B power n plus C power n? This is A power n R power n plus A power n R square power n, which is R power 2n. And what does this simplify into? We can take out A power n common, we can take out R power n common. A power n, R power n can come out common. What remains is this, 1 plus R power n. Yes. C power n plus D power n can again be written as A power n R power 2n plus D power n will be A power n R power 3n, which can be written as A power n 1 plus R power n, and you can take out R power 2n common from here, which is R power n square. And from these three expressions, from 1, 2 and 3, do you realize that A power n plus B power n, B power n plus C power n, C power n plus D power n are in GP with first term this common ratio R power n, as you can see over here. From 1, 2 and 3, the terms A power n plus B power n, comma, B power n plus C power n, comma, C power n plus D power n are in GP with common ratio is equal to R power n, where R is the common ratio of original given GP. That's what you can observe, right? Okay, that's question number 17 for us, and that's a complete proof of this. Question number 18 says, if A and B are the roots of this equals 0, C and D are the roots of this equals 0, where A, B, C, D form a GP, prove that Q plus P is to Q minus P is equal to 17 is to 15. So A and B are the roots of x square minus 3x plus P equals 0. This is one of the equations which is given, whose roots are A and B. And what does this imply? This implies that A plus B is equal to 3, AB product is equal to P. This is what we know. The other equation is x square minus 12x plus Q equals 0, and the roots are C and D. This implies C plus D is equal to 12, CD product is equal to Q. That's what we know. ABCD form a GP. If it is given that ABCD form a GP, then Q plus P and Q minus P ratio is being asked, right? So if ABCD are in GP, and I know A plus B, I know C plus D, can I form that GP in terms of two variables, that is A and common ratio R? Yes. Let B is equal to AR, C is equal to AR square, D is equal to AR power 3. If we can do this using 1, 2 and 3. Using 1, 2 and 3, 1, 2 and 3 implies that A plus B, which is A plus AR, is equal to 3, and CD, which is AR square plus AR power 3, is equal to 12. That tells me A times 1 plus R is equal to 3, and this tells me AR square 1 plus R is equal to 12. Dividing these two will tell me that R square is equal to 12 by 3, 4, which implies R will be equal to 2 or R equals minus 2. R equals 2 or R equals minus 2. If R is equal to 2, using this equation, therefore A will be 1 plus 2, 3, A will be 1, or A will be 1 minus 2, which is minus 1, minus 3 is the answer in this case, right? Okay, and we have solved these two equations to get the values of A and R. Can we also check? First of all, let's check this. A plus B is equal to 3, is that okay? B will be equal to what? B will be A times R, which is 2, C will be 4, and D will be 8. B in this case will be 6, C in this case will be minus 12, and D will be 24. That's what you observe, right? So these are the terms A, B, C, D, A, B, C, D. A plus B is 3, which is okay, C plus D is 12, which is okay in these two cases, right? Is there anything else given where A, B, C, D form a GP? Prove that Q plus P is to Q minus P is equal to 17 is to 15. We are supposed to prove that. Let's take a look at both of these, okay? Q plus P upon Q minus P. Therefore, Q plus P over Q minus P is equal to what? Q is CD and P is AB. This is CD plus AB upon CD minus AB, and this is equal to, what is this equal to? Let's take a look at this. CD is 32 and AB is 2 upon 32 minus 2. What is that? 64 upon, this becomes, this is equal to 64 upon, 34 upon this. Why am I writing 64? This is 34 upon 30, which is 17 upon 15. Okay, this is what we wanted to prove. But or we have another expression over here. This or this Q plus P upon Q minus P is equal to, again, CD plus AB. CD is 24 into minus 12. What is that? Minus 288 plus AB. AB is minus 18 over CD minus AB, which is minus 288 plus 18. And what does this simplify into? Minus 288 minus 18 will be 306, minus 306. And what is this? Minus 288 plus this will be minus 270. Is it? Please take a look at this. Is this minus 270? 270 and 18 is 288, yes? And what does that simplify into? 306 and 270. This goes with 9, first of all, in the numerator and denominator. Yes, 9 gets. Then you can also divide with, can you divide with 6 as well? Yes. So 9 times 2, 18. It goes with 18 in the numerator, 18 in the denominator. Let's take a look at this. 18 in the numerator, 18 in the denominator can be cancelled. So this minus becomes a plus. And if you only divide with 9 for that matter, what does it become? This becomes 3 and 4, 34 upon, this becomes 30, right? And which further reduces to 17 upon 15, as you can see over here. Right, so Q plus P upon Q minus P in both these cases is 17 upon 15. As you can see, this complete solution over here, and that's a complete proof for this question number 18th. Question number 19 says the ratio of the arithmetic mean and geometric mean of two positive numbers A and B is m upon n. Show that A is to B is equal to this. Okay, ratio of the arithmetic mean and geometric mean of two positive numbers. Okay, A and B, A comma B are greater than 0, and the ratio is equal to m upon n. That's what the person is saying, right? No. Of two positive numbers, the arithmetic mean, ratio of arithmetic means to geometric mean. Okay. Two positive numbers A and B. This implies arithmetic mean will be A plus B by 2, comma geometric mean will be square root of AB. And it is given that A upon G is equal to m upon n. Okay, what else? So this can be written as A plus B by 2 root AB is equal to m upon n. This is what I know. Yes? Yes. Okay, since the numbers are positive, A upon this will be root of A by B plus root of B by A, and you have 1 by 2 outside. This will be equal to m upon n. Let square root of A by B is equal to new variable t. If you assume this, then we have simply divided and separated them out, and now we want to make a quadratic in terms of root A upon B What does that tell me? 1 times 1 by 2 times t plus, this is reciprocal, 1 upon t is equal to m upon n. And this further tells me, okay, t square plus 1 times n, t square plus 1 times n is equal to 2tm, and this becomes nt square minus 2mt plus n is equal to 0. This is what you get, right? What will be the value of t? T can be found using the quadratic formula, minus b plus minus under root of b square minus 4 into a into c upon 2a. You can see 4 under root will be 2, and 2 will get cancelled. This leaves us with m plus or minus under root of m square minus n square over n. This is what remains, right? But what is this value? This is t. This is square root of a upon b, first of all. Okay, we can choose m plus or m minus. We can choose either one and continue further, right? We need to square this expression. Yes, we need to square this expression. So let's move ahead and see. This tells me a upon b is equal to m plus square root of m square minus n square upon n and its square, or a upon b is equal to m minus under root of m square minus n square upon n and its square. This is equal to this or this. Now what do we do? So this is m plus, and do you see that we need a single m plus and m minus in the denominator, right? So we need that kind of expression. This is what we have. So m plus this, what is that? Where does that take me? This is m plus square root of m square minus n square times this very expression, right? Okay, and I want to rationalize one of these, right? So I multiply and divide with n is already there, m minus square root of m square minus n square. I divide with this and I multiply the other expression by this. Since there is a square over there, yes. Okay, this becomes n square over here. And when I multiply this with this, what do I get? M square minus m square plus n square. This goes away. This is n square, which further gets cancelled with this n square. Yes, and what remains is m plus under root of m square minus n square upon m minus under root of m square minus n square. This is the value of a upon b that is required, but you will get another value, or a upon b, similar steps of rationalization of one term in the numerator will give me m minus under root of m square minus n square upon m plus under root of m square minus n square. Right. So are these both correct? Yes, these both are correct. The ratio, when the person says the ratio is to be found, the ratio of the two numbers a and b, it is not given which of these is greater. If a is greater, if b is greater, so we can get this or this both as the possible answers, and that's the complete proof for this one, right? Show that this is to b is equal to this. That's what we have done. But you should be aware, okay, this can be equal to this as well. Is that all? Yes. Is there any other thing given in this question to differentiate between these two? Frankly speaking, no. The ratio of the arithmetic mean and geometric mean of two positive numbers a and b is m is to n. There's nothing else given other than that. And that's all that you have in this question. Question number 20, it says, if ABC are in AP, BCD are in GP, and 1 upon C, 1 upon D, 1 upon E are in AP, prove that ACE are in GP. Okay. So ABC are in AP, which it is given, A, B, C in AP, B, C, D in GP, 1 upon C, 1 upon D, 1 upon E in AP again. Prove that is ACE. So we are supposed to talk about ACE after this. Alright. ACE are in GP. How will we go about doing this? To prove ACE in GP, we need to prove that C square is equal to AE. This is our target, right? Somehow, let's get through this. So one of the ideas is you begin with 2b is equal to a plus c, okay? You have c square is equal to bd. Okay, so between these two you eliminate b. You get a relation between AC and D, and then you get another value of D from here, and you eliminate D in this. Let's try using that idea first of all. That's one of the ideas without assuming anything, without assuming the numbers as A plus D, A plus 2D and all. Let's do that. So 2B is equal to A plus C. Then you have C square is equal to BD from here. And you have 2 upon D is equal to 1 upon C plus 1 upon E from here. Yes? I can eliminate B between these two, and where does that take me? So this is 2B. B is C square upon D is equal to A plus C. Okay. Then I can eliminate between this and this, I can eliminate D. So 2 upon D is 1 upon C plus 1 upon E times C square, that is equal to A plus C, as you can see over here. Now we have a relation between AC and E, and let's rearrange this relation to see where does that take me. So this is, we need C square is equal to AE, something of that sort. Okay, let's try to simplify this. What do we have? This is C plus E upon CE into C square, which is A plus C over here. This C goes with C square, so that becomes C square plus EC is equal to AE plus EC. EC goes with EC, that tells me C square is equal to AE, or you can say that ACE are in geometric progression. That's the proof for this question, as you can see over here using this simple idea. Yes? Question number 21 says, find the sum of the following series up to n terms. And we have seen this kind of a series, 8, 88, 888. The idea for solving that kind of series is you take out 8 common, then you multiply and divide with the 9 as well, right? So similarly, in the first part, what we'll do is S is equal to 5 plus 55 plus 555 plus dot dot dot. So I take out a 5 common, I divide with the 9 and I multiply with the 9 to give me this. This is what you will be getting, right? And this series 5 by 9 is okay. In the bracket, I get 10 minus 1 plus 10 square minus 1 plus 10 power 3 minus 1 plus dot dot dot. And once you see this, this is 10, 10 square, 10 power 3 up till 10 power n. The sum will be a geometric progression having first term 10, common ratio 10 power n minus 1 upon 10 minus 1 minus 1 minus 1 minus 1, that is minus n times this, right? N terms. And this becomes 5050 upon 9 times 9 is 81 times 10 power n minus 1 minus 5n by 9. That's my required answer for this first part, as you can see over here. Is that okay? Yes. What about the second part? Do we have a similar thing in the second part? Yes. This is 0.6 plus 0.66 plus 0.666 plus dot dot dot. What I will do is I'll take out a 6 common, multiply and divide with 9. So this becomes 6 upon 9. In the bracket I get 0.1, 0.9, 0.99, 0.999 plus dot 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 dot. What does this simplify into? 6 by 9 is okay. This is 1 minus 0.1. So 1 minus 10 power minus 1 plus 1 minus 0.01, which is 10 power minus 2 plus 1 minus 10 power minus 3 is what you get, plus dot 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 dot. Similarly this. So you see 6 by 9 comes out common and we get a similar kind of a series, just that there were 10 power 1, 2, 3. Here we have 10 power minus 1, minus 2, minus 3. This 1, 1, 1 will add up n times and this will become n, minus you have 10 power minus 1, 10 power minus 2, 10 power minus 3. The common ratio is 1 upon 10, which is 10 power minus 1. The first term is 10 power minus 1. The common ratio is 10 power minus 1 raised to power number of terms upon 1 minus 10 power minus 1 is what you get. That's the complete summation of the second terms. 6 by 9 is okay. In the bracket I have n minus, this is 1 upon 10. Okay, I multiply 10 inside. This becomes 10 minus 1, which is 9 in the denominator. And what about the numerator? Numerator we have 1 minus 10 power minus n. This. And multiplying this inside, this is actually 2 by 3. It goes inside. This becomes 2n by 3 minus 2 by 9 times 3 is 27. 2 by 27. 1 minus 10 power minus n is what I get. That's my required answer for this first and second part in this question number 21, as you can see over here. Question number 22 says find the 20th term of the series this. Okay, so what do we have? We have 2 into 4 plus 4 into 6 plus 6 into 8 plus dot 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 n terms. What are we interested in? We are interested in the 20th term of the series. This here is the first term, A1, A2. We can use T1, T2 as well, but this is A3. And similarly, if I want AN, what will that AN look like? So 2, 4, 6. You can observe this is a arithmetic progression. AN will have 2 into 1, 2 into 2, 2 into 3, 2 into n first term. Then you have 2 plus 4, 2 plus 2, 4 plus 2, 6 plus 2 just over that. 2n plus 2 is what will come over here in the product. Okay, by observation we did this. Therefore, A20 is equal to 2 into 20 into, this is 2 into 20 plus 2 in the bracket. What is that? 40 into 42 is what we are looking at. This is 168, right? 0. That's my required answer for this question number 22, as you can see over here. Question number 23 says find the sum of first n terms of the series. Right? What do we have? So S, first n terms, Sn will be 3 plus 7 plus 13 plus 21 plus 31 plus dot dot dot. Okay, there will be some nth term. Is this some kind of a arithmetic progression or geometric progression type of thing? If you observe carefully, it is neither. The differences 4, 6, 8, 10. The differences are in the arithmetic progression, right? And the way of handling this is by taking differences, by writing Sn again. So what we'll do is write Sn again by shifting each term by 1 unit. 3 plus 7 plus 13 plus 21 plus 31 plus dot 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 plus an. And now you take the difference. Subtract these two. Okay. Sn minus Sn becomes a 0. This is 3. This here is 7 minus 3, 4 plus 6 plus 8 plus 10 plus dot dot dot, and up till here minus an. 0 minus this will be an. Do you observe? From here 3 to an we have n terms. So up till here you will have n terms starting from 3. If you see, you can miss out 3 and say this is 4 to something, and these are how many terms? We have n minus 1 terms left over here. And these n minus 1 terms are forming some kind of a pattern, right? This is an arithmetic progression, yes? I can easily get the value of an by bringing this an from here to the left hand side. An is equal to 3 plus. This is an arithmetic progression having n minus 1 terms. The sum will be n minus 1 by 2, 2 into first term, plus number of terms minus 1, which is n minus 2, times the common difference is 2. This is what you get, and this is how you'll find the value of an. Okay. This 3 is okay, plus n minus 1 by 2 is also okay. What does this simplify into? This is 8 plus 2n minus 4. Okay. 2n plus 4 is what you get. You can take out, you can cancel that factor of 2. N plus 2 is what I'll get. Is that okay? Yes, please take a look at this. 2n plus 4 divided by 2 will be n plus 2. And this further simplifies into n square. Plus 2n minus n is plus n and plus 1. This is what you get. An is n square plus n plus 1. And now once we have an, can we find Sn? Sn is summation of r is equal to 1 to n, which is summation of r square plus r plus 1 from r is equal to 1 to n. What is that? Summation of r square plus summation of r plus summation of 1. This here is 1 square, 2 square, 3 square, sum of squares of natural numbers. What that becomes n plus 1, 2n plus 1 over 6. Summation of r, that becomes n plus 1 by 2 plus summation of 1 n times. That is simply n, right? This is what you get. n comes out from the numerator, 6 comes out from the denominator, and what does remain? N plus 1, 2n plus 1 remains from the first term, plus n by 6 comes out common, so 3 times n plus 1 will remain over here, plus n has gone, 6 will come over here. This is what you get, right? N by 6 is okay. In the bracket you have 2n square plus n plus 2n is plus 3n plus 1 plus 3n plus 3 plus 6. And this will simplify to n upon 6 is okay. This is 2n square plus 6n plus 10. Right? Yes. 10 times 2 is 20. Can I factorize this? I don't think so, right? No. I can simply divide with 2. N by 3 remains. This is n square plus 3n plus 5. That's my required answer for this question number 23, as you can see over here. Question number 24 says, if S1, S2, S3 are the sum of first n natural numbers, their squares and their cubes respectively, show that 9 times S2 square is equal to S3 times 1 plus 8 S1. That's what we are looking at. Okay. So S1, S2, S3 are the sum of first n natural numbers. S1 is equal to n times n plus 1 by 2. S2 is equal to n plus 1, 2n plus 1 over 6. S3 is n square, n plus 1 square upon 4. This is what you have. For S1, S2 and S3, okay, show that this expression is equal to this expression. Now how do we prove that? To prove 9 times S2 square is equal to S3 times 1 plus 8 S1. So what are we interested in? This looks relatively simple. This is more complicated. So let's begin with the RHS. RHS is S3, n square, n plus 1 square upon 4. In the bracket we have 1 plus 8, n plus 1 upon 2. This is okay. N square is okay. N plus 1 square is okay. 4 is okay. What does this become? This goes 4 times. So this is 4n square plus 4n plus 1. Is that okay? Yes. This 4n square plus 4n plus 1, which is a perfect square in itself. Yes. So this tells me RHS will be equal to n square, n plus 1 square, and this here is nothing but 2n plus 1 whole square upon 4 is already there. For converting this into S2, I need square of 6, actually 36. So let's multiply with the 9 in the denominator and numerator respectively. This becomes n plus 1, 2n plus 1 upon, this is 36 and its square times 9. This is S2 square times 9, which is 9 S2 square, which is equal to the LHS. And yes, that's the complete proof of this particular 24th question, as you can see over here. Question number 25 says, find the sum of the following series up to n terms. Okay, sum of this series up to n terms. If you can observe, this is T1, this is T2, this here is T3. Okay, so what will Tn look like? First, let's find Tn. Once you find Tn, after that we'll think of finding the sum. So Tn will have, in the numerator you will have cubes, 1 cube, 2 cube, dot 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 up till n cube. In the denominator you will have 1, 3, 5, dot 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 up till 2n minus 1. This is sum of odd natural numbers. Okay, sum of odd natural numbers, and that is pretty simple to find, right? Sum of first n odd natural numbers is n square. In the initial few exercises we have seen this, proved this. So you'll also remember this. The sum of first n odd natural numbers is simply n square. You can also find that because this is an arithmetic progression. Number of terms is n. N by 2, first term plus last term, that is 2n minus 1 plus 1, which is 2n. So n times 2n by 2, which is n square. This is what you get, right? What about the sum of cubes? This is n square, n plus 1 square upon 4, divided by you have n square. This becomes simply n plus 1 square upon 4. Is that okay? That's Tn for us, yes? Okay. Sum of the following series up to n terms is what we are interested in. Sn will be summation of 1 by 4 n plus 1 square. 1 by 4 can come out common. In the sigma we have n plus 1 square, putting n equals to 1, that gives me 2 square. Then you have 3 square plus dot 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 up till n plus 1 square. Do you see, this is sum of all squares of natural numbers except for some particular term which is missing from the beginning. Let's give that term and let's subtract that term. What's the issue? There's no issue, right? And now I can write 1 by 4 is okay. This is sum of first n plus 1 squares. That is, instead of n you will have n plus 1 in the formula. So n plus 1 plus 1 will become n plus 2. 2 times this plus 1. So 2n plus 2 and plus 1 is plus 3 upon 6 in the bracket and with a minus 1. That's what you have, right? Sum of the following series up to n terms is this. This simplifies to n plus 1. Just a minute. N plus 1 is there, yes. N plus 2 is there, yes. 2n plus 3 is there, yes. Upon 24 is there, yes. Minus 1 by 4. And we can leave the answer at this stage, or maybe we can simplify by taking the LCM over here. What's the numerator? Numerator looks like, okay, can we multiply them? This is n square plus 3n plus 2. And we have 2n plus 3 as well. It's n square plus 3n plus 2 times 2n plus 3 is what you have upon, okay, this will be, you take the LCM, this becomes 6 and this becomes 24. You actually see 3 into 2, 6 getting cancelled, right? The constant term gets cancelled. What about the n power 3? That's the first term, plus 3n square. 3 times 2 is 6n square. That becomes 9n square plus 9n plus 4n is 13n plus 6 minus 6 over 24 is what I get. So at this stage, or this looks pretty simple now, n by 24, n comes out common, 2n square plus 9n plus 13 is my final answer, this or this, okay, this is better. So that's the final answer for this question number 25, as you can see over here. In question number 26, we have show that this equals this, prove that question. Okay, so the left hand side looks a bit complicated. Let's try to simplify this. Left hand side is equal to 1 into 2 square plus 2 into 3 square plus dot 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 plus n into n plus 1 square. In the denominator you have 1 square into 2 plus 2 square into 3 plus dot 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 plus n square into n plus 1. That's what you have, right? Right? Numerator and denominator. This let this be called, in the numerator let's call this small sn, and in the denominator let's call this capital Sn. Okay, and now our focus is on finding small sn and capital Sn separately. Small sn is equal to sigma of this nth term, n times n plus 1 square, from n equal to 1 to n. That's what we are interested in, right? This will be sigma. Let's multiply this and see where does that take me. So if you can observe, n square into n will be n power 3 plus 2n times n will be 2n square plus 1 into n will be n. This is what you get, right? Okay, and this will simplify into summation of n cube is n square, n plus 1 square upon 4 plus 2 times summation of n square will be n plus 1, 2n plus 1 upon 6 plus summation of n will be n plus 1 by 2. Please observe this carefully. Summation of n cube is n square, n plus 1 square upon 4. 2 is okay. N square summation will be n plus 1, 2n plus 1 by 6. Summation of n will be n plus 1 by 2. Can we take out something common? Yes. This will be a 3. Yes. From the numerator I can take out n plus 1 common. From the denominator 4, 3, 2. I have the LCM as 12. Let's take out 12 common. What it means is 3n times n plus 1 over here from the first term. Yes. From the second term I have 4 times 2n plus 1 remaining, and in the next term we have n plus 1 by 2, a 6 remaining over here. This is what you have. This is what you have, right? Okay. So small sn simplifies to n plus 1 upon 12 times this whole expression in the bracket. What is that? 3n square plus 3n plus 8n is 11n. 4 plus 6 is 10. This is what you get, right? 10 times 3 is 30. So this can further be factorized. Yes, n plus 1 by 12 is okay. 3n square plus 6n is what you'll get. So one of the factors will be n plus 2, the other factor will be 3n plus 5. This 3n square plus 5n plus 6n is 11n plus 10, right? That's what we have for small sn. What about the other one, capital Sn? Let's focus on this capital Sn, which is the denominator of the LHS, right? Okay, that's sigma n square times n plus 1. N equals 1 to n. What is that? Sigma of n power 3 plus n square. This is what you have. What sigma n power 3? This is n square, n plus 1 square upon 4 plus sigma n square is n plus 1, 2n plus 1 upon 6. This is what you have, right? So you can take out n common, n plus 1 common, and in the denominator you can take LCM as 12. What remains is 3n times n plus 1 plus 2 times 2n plus 1. This remains. Is that okay? Yes. Please take a look at this again. N square, n plus 1 has been taken out common, then you have 12 taken out common from here, and this is what you'll be getting. n plus 1 upon 12 is okay. In the bracket, what do we have? This is 3n square plus 3n plus 4n is 7n plus 2. And 3 times 2 is 6. You can write 7 as 6n plus n. Factorizing this. This will be 3n square plus 6n. One of the factors will be n plus 2. The other factor will be 3n plus 1. Right? 3n square plus 6n plus n is 7n, and plus 2 is what you get. So you have found capital Sn, you have found small sn, and now the only thing that remains is to simply write the LHS. Therefore, LHS will be equal to small sn upon capital Sn. Again, write this whole expression divided by this whole expression over here, but you can see n plus 1 by 12, n plus 1 by 12, n plus 2 goes away, and what remains is 3n plus 5 upon 3n plus 1. Is this what we wanted to prove? Yes, this is exactly what we wanted to prove. That's the complete right hand side and the complete proof for this question number 26, as you can see over here. Question number 27 says a farmer buys a used tractor for rupees 12,000. He pays 6,000 rupees cash and agrees to pay the balance as annual installments of rupees 500 plus 12% interest on the unpaid amount. Pretty interesting. How much will the tractor cost him? Okay, on the unpaid amount, that's what you're looking at. Used tractor for rupees 12,000. He pays rupees 6,000 cash and agrees to pay the balance in annual installments of rupees 500 plus 12% interest on the unpaid amount. Okay, 12% interest on the unpaid amount is the key. So, how much will he pay? So, 500, 500, 500 up till this annual installments. Annual installments will imply 12 installments, right? Unpaid amount. Pays rupees 6,000 cash. Annual installments of rupees 500. What does that imply? That implies that, okay, from the remaining 6,000, some interest would have accumulated, right? So he pays 500 out of that 6,000 and plus the additional interest that has been accumulated over there, interest over 6,000. At the end of the next year, what does he have? So he pays 500 plus additional interest on the remaining amount. Remaining amount was 5,500 because he has already paid 500 before. So on the remaining amount 5,500, he pays an interest of 12%, right? Annual installments, that's the important thing, that these are not monthly installments, these are annual installments. Yes, yes, annual installments of rupees 500. Okay, so the extra amount that he pays is the interest, 12% interest on, okay, he pays 6,000 initially plus 500 and plus 500 plus 500 plus 500, 12% of remaining, that is 6,000 in this year, second year, right? Plus he pays another 500 plus 12% of 5,500 because that's the remaining amount. He has already paid 500 over there. Plus he pays another 500 and 12% of 5,000 plus so on and so forth. And how many times? This 500 will happen 12 times. 500 comes 12 times, right? Okay. And this 6,000, 5,000, 500, 5,000 reduced to automatically 500 over here, right? Okay. So that's a total of 12 terms plus 6,000 rupees extra. Okay. So he pays this much amount. S will be equal to 6,000 plus remaining 500 times 12 will be 6,000. That's 12,000 plus some other series. What's that? 12% of 6,000, 12% of 5,500 will be actually 12% is 12 upon 100 of 6,000, or you can have 5,500, or you can have 5,000, and so on and so forth. This is 12 terms actually. The last term will be 500 out of this, right? 12 terms. The last term will be this. This is what we are interested in. This is an arithmetic progression which is very simple to handle. Yes, 12,000 is okay, plus 12 upon 100 is also okay. You can take out a 500 common from here. What remains is 12 plus 11 plus 10 plus dot 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 up till 1. Right, this is sum of natural numbers, which is easy, which is very easy to handle, right? 100 goes with these two zeros. This becomes 12,000 plus 60 times sum to 12 numbers. This is 12 into 13 by 2. Yes? Yes, this is 6. And this simplifies to, which implies amount paid S is equal to 12,000 plus, what is this? 6 into 6 is 36. 36 into 13 is what we are interested in. Or for that matter, 13 into 6 is 78. 78 into 6. You can find 36 into 13 easily. That's 6, 3, 18, 8, 1 carry 3, 3, 9 plus 6 is 15 plus 1 is 16. You get 3, 1, 3, 4. 4, 6, 8 is what you get, right? So 4, 6, 8, 0 is the extra amount that he has paid, right? That's what he has paid on this amount. What else? 12,000 plus 4680, that becomes equal to 16,680 rupees. So that's the final amount, and rupees 16,680 is my answer for this question. That's the net he needs to pay for buying that tractor after paying 6,000 in cash and agrees to pay the balance in annual installments of 500 plus 12% interest. How much will the tractor cost him? This is the amount, right? That's the final answer for this question number 27, as you can see over here. Question number 28 says, Shamshad Ali buys a scooter for rupees 22,000. He pays rupees 4,000 cash and agrees to pay the balance in annual installments of rupees 1,000 plus 10% interest on the unpaid amount. Similar to the previous question. And here, what do we have? How much will the scooter cost him? Okay, so let's the total sum that he pays is 4,000 plus cash and agrees to pay the balance in annual installments of rupees 1,000 plus 10% interest on the unpaid amount. So 10% of unpaid amount. Unpaid amount is 22 minus 4, which is 18,000. Right? So in the next year, what will happen is he has already paid 1,000 more. So remaining unpaid amount is 17,000. Interest will be charged at 17,000, and he pays 1,000 in that month plus the interest, 10% of 17,000, and plus so on and so forth. Right? This is what you have. So this is 4,000 plus, you can take out 1,000, 1,000, 1,000. How many times will the 1,000 occur? There are total 18 terms remaining, so 1,000 into 18 will remain, 18 terms. Okay. Plus 10%, which is 10 upon 100 of 18,000, of 17,000, of 16,000, and so on and so forth. So you'll have 18,000 plus 17,000 plus so on and so forth. 18 terms in all, what you'll have, the last term will be 1,000 basically. This is what you get. Is that okay? Yes. This 4,000 is okay. Plus this is 18,000, which is also okay. Plus this is 1 by 10. And the sum over here is total 18 terms. 18 by 2. First term 18,000, last term this is 19,000 is the total. This. Okay. And what does this simplify into? Let's take a look at this. This goes away 9 times. This 0 cancels this. And we get this 18 plus 4 is 22,000 plus this is 9 into 19 will be 171,000, 171,000. This is what you get. Is that okay? Yes. So the total amount paid implies total is equal to total cost of the tractor will be 22 plus 17 is 39,100. rupees 39,100. And that's my required answer for this 28th question, as you can see over here. Yes, question number 29 says a person writes a letter to 4 of his friends. Okay, he asks each one of them to copy the letter and mail to 4 different persons with instruction that they move the chain similarly. Okay, right, chain is being formed over here. And what else? Assuming that the chain is not broken and that it costs 50 paise to mail one letter, find the amount spent on the postage when 8th set of letter is mailed. Okay, amount spent on postage. So there are two things, there are two meanings basically which can be seen over here. Amount spent on when the 8th set is mailed, the amount on that 8th set can be asked, that's one thing. Or the person may ask the total amount spent, the total amount spent, and I think these people want the total amount spent on the postage when the 8th set of letters is mailed, right? So we'll find both the values over here, that amount spent on the 8th postage and total amount spent as well. Okay, 4 of his friends. So first mail will have how many letters? First mail will have 4 letters. Second mail, when you talk about second mail, how many letters will it have? So second mail will have, each friend mails to 4 more friends, so that is 4 into 4, actually 16. The third mail will have 4 into 4 into 4 again letters. Yes, and similarly what you can observe is that 8th mail, when we talk about 8th mail will have 4 power 1, 4 power 2, 4 power 3, 4 power 8 letters. Okay, this is what you'll have, right? The amount spent on 8th mail is equal to rupees 0.5, 50 paise into number of letters, which is 4 power 8. This is the amount spent on 8th mail. And what does this come out to be? 4 power 8, this 1.5 will be 1 upon 2. So 1 upon 2, 2 power 16, this becomes 2 power 15. And what's 2 power 15 equals to? So 2 power 10 is 1024, then you have 2048, 11. 2048, then 4096, then 8192, and then you have 8 and 16 and 32. So this becomes 32 and 8192, 192 into 4 actually is what we are interested in. That's 19 into 4 is 7876, and 2 into 4 will be this 8, right? This is what you get, 32768. This is the amount spent on 8th mail. And what about the total amount? The person should have clearly mentioned whether he is asking this or this. Total amount when 8th mail is being conducted, total amount. So when 8th mail is posted will be sum total of all of these letters into 0.5. 0.5 into that 4 plus 4 square plus 4 power 3 plus dot 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 plus 4 power 8. That's what you're interested in. And what's this? This is 1 by 2, which is okay. This is a geometric progression. Sum will be 4, the first term, common ratio power number of terms minus 1 upon common ratio minus 1. What is that? It's 4, 2 into 3 is 6. So this becomes 2 upon 3, and in the bracket what do we have? 4 power 8 minus 1. 4 power 8 will actually be, this is 2 power 15. So 2 power 16 will be double of this. Right or not? Yes. 2 power 16 will be double of this. What is that? 64, and then you will need 65 as well. So 8, 8, 16, 6, 1 carry, and what else? 6, 6, 12, 1, 13, 3, and 1 carry, 14, 1, 15, 1, 5, and 1 carry, that is 6, 5, 5, 3, 6 is what you get. 6, 5, 5, 3, 6. And minus 1 is what we are interested in, right? Is that okay? Yes. 4 power, number of terms is 8, common ratio is 4, this is what you get. 2 by 3 is okay into what does this amount signify? This is 6, 5, 5, 3, 5, okay. 69 and 15, this goes with 3, yes. This becomes 2, 1, 8, 12 will go 4 times and 15 will go 5 times. This is 2, 1, 8, 4, 5, which is multiplied by 2, it becomes 90 and 36 and 4, 3, 6, 9, 0. That's the amount. That's the other possibility. If the person is asking the total amount, this is the solution. Amount only on the 8th mail is this, right? That's what we have. That's the final calculation for this. And the NCERT people have actually given this 43690, I suppose. And that's the final answer for this 29th question, as you can see over here. In question number 30th, what does the person say? A person deposited rupees 10,000 in a bank at the rate of 5% simple interest annually. Now, mind you, simple interest does not add to the amount, so interest will remain same throughout. Okay. So, what is the simple interest? Simple interest will be 5% of simple interest each year. Basically, will be 5% of 10,000. What is that? 5 upon 100 into 10,000. Two zeros get cancelled. This is 500, right? That's what we have. First of all, we have found the interest. Find the amount in the 15th year since he deposited the amount. In 15th year, not at the end of 15th year, in 15th year is the person asking. In 15th year, so he would have received interest up till 14 years, right? 14 year interest, 14 into 500 interest plus principal. What is the principal? Since you want the amount, principal has to be added. Principal is 10,000. So what is that? 14 times 5 is 7,000 and 70 and 7,000. This is 17,000 is my answer in 15th year. And what else? Total amount after 20 years. Okay, after 20 years. When you talk about after 20 years, so interest will have been received for 20 years. This is this 20 into 500 plus 10,000 initially. And this 20 times 5 is 100. 100 into 00 is 10,000. This becomes 20,000. And that's my answer for the second part. That's question number 30th for us, as you can see over here. In question number 31, the person says a manufacturer reckons that the value of a machine which costs him rupees 15,625 will depreciate each year by 20%. Find the estimated value at the end of 5 years. That's what we are interested in. Reckons that the value of a machine which costs him this much depreciate each year by 20%. So the remaining value, basically, if 15,625 is the initial price, at the end of 1 year 20% will be depreciated. So the remaining value will be 80%. 80% is 80 upon 100, right? At the end of 1 year, this will be the value. It's similar to the discount concept that we have. Find the estimated value at the end of 5 years. Okay, at the end of 1 year this happens. Then at the end of second year, another 80 by 100 comes multiplication, and so on and so forth, right? So 1 year will be 80 by 100 power 1. 2 years, at the end of 2 years, 80 by 100 power 2. At the end of 5 years, we'll get at end of 5 years, the value will be equal to 15,625 into 80 upon 100 raised to power 5 at the end of 5 years, right? This is 15,625, which is okay. This is 4 upon 5, 4 power 5 upon 5 power 5. Okay, what is 5 power 5 equal to? That is, it's 5 power 3, 625. Then there's 3, 1, 2, 5. And is this 15,625 only? Let's check that. So we can divide by, I can see 6 to 5 being formed. Let's divide by 25 first. So 25, and if I take 25, this is 5 power 3, right? And what does this become? This is 25 times 6 is 150. 150, then you have 62, 2 times, and 125, 5 times. 625 is what you get. So this is 625, this is also 625, right? No, this is 125. So you have a 5 remaining in the numerator, and 5 into 4 power 5 is 2 power 10. 2 power 10 is 1024. This is 5 into 1024. What is that? 1024, 5 into 24 will be 120, and 5120 is what you get. That's my required answer. Estimated value at the end of 5 years is 5120. That's the correct answer for this. Question number 31, as you can see over here. Question number 32 says 150 workers were engaged to finish a job in a certain number of days. Okay, 4 workers dropped out on second day, 4 more workers dropped out on third day, and so on. Okay, it took 8 more days to finish the work. Find the number of days in which the work was completed. That's what we are interested in which the work was completed, not the initially decided days, but in which the work was completed. How will we handle this? So this is related to some work and some people involved in doing the work. If you observe, how are the calculations being done over here? So if there are 150 workers assigned to a particular task, they work for some, let's say 10 days. So total number of man days can be counted. 150 workers into 10 days will be 1500 man days of work. Let's say if you have lesser number of workers, the number of days will increase. If you want more workers, the number of days will decrease, right? That's what you can easily calculate. So net total work is roughly 1500 man days. That's what you count. If you engage 500 workers, the number of days that will required will be 3. That's a simple calculation, right? Although in real life there are other situations also that this work has to be finished before, this work has to be finished before, but in general, in these type of questions in simple mathematics, what we'll encounter is number of man days, right? Okay, so let's compare the number of man days initially decided and finally obtained. 150 workers were engaged to finish a job in a certain number of days. Let n days were decided initially. Okay. So total work, total man days, you can say, total man days required will be n times 150. That was plan, right? That was the plan, 150n. But what happened was actual man days will be how many? Actual man days will be, although this and this has to be equal, but actual man days on the first day you had complete 150, on the second day 4 dropped. So 150, then you had 146, then you have 142 and so on. How many terms will be here? 8 more days were taken to finish the work. So this is n plus 8 terms. Is that okay? Yes. What does this become? So you know the number of terms, and do you see that this is a arithmetic progression having common difference minus 4. So number of terms is n plus 8 upon 2. Yes. 2 into this, which is 300, plus number of terms minus 1, which is n plus 8 minus 1, times common difference, which is minus 4. This is what you get. Let's simplify this. This is n plus 8. Multiply this 2. This is 150 minus 4 divided by 2 will be minus 2. So this becomes minus 2n and minus 14. This is what you get. So n plus 8 is okay. And this is 136 minus 2n. If you can observe this carefully, this is what you get. What is happening? The number of man days required and the actual number of man days should be equal. Let's equate them and solve for the value of n. So therefore 150n is equal to this product, n plus 8 times 136 minus 2n. And what does this become? This is minus 2n square. 136n minus 16n is 120n, and you have 8 into 136. Okay, plus 8 into 136 is what you get. That's what you have, right? Let's bring everything on the left hand side. This is 2n square plus 30n minus 8 into 136 is equal to 0. This is what you get, right? Now I want to factorize 8 into 136 into 2. Factorize this. 8 into 136 into 2, which is 16 into 136. Okay. 136 can further be factorized as, let us write 16 as it is. 136 can be divided by 4, and this becomes 34, right? This is what you are getting, yes? 16 times 4 is 64, this is 34. 64 and 34, the difference is 30, yes? So 2n square plus 64n minus 34n minus 8 into 136 is equal to 0. This is what I can write it as, yes? 2n will come out common from here. What remains is n plus 32. Minus 34 will come out common from here. 16 into 4, 64 will remain. Yes or no? Yes. Or 34 comes out common. N plus 32 remains. Yes, 32 will remain. Not 64, 32 will remain. This is what you get. This is equal to 0. That tells me the value of n will be minus 32, or the value of n will be 34 upon 2, which tells me n will be equal to 17. Now the answer is not n. How many days actually took to solve this, to complete this work? So number of actual days required is equal to n plus 8, which is 17 plus 8. 17 plus 8, which is 25. That's my answer for this question, as you can see over here with this calculation. Yes. And with this, we come to the conclusion of this miscellaneous exercise as well as the chapter sequence and series. Till the next video, all the best.